Okay. So as you know, we're taking these last 2 weeks to kind of teach ourselves how to do the 3 kind of major skills that are left in our book. And we're eliminating all those little kind of mini things that it has throughout the chapter and going right to the guts of what you need to know, okay? So for example, in chapter 9, the title of chapter 9 was How to Divide Fractions. So instead of taking that chapter and working it in tiny little pieces, we just went right to the meat and we said, what are we gonna learn how to do? We're gonna learn how to divide fractions. And we did that. And so I feel pretty confident that today, all of you, if you were asked how to divide fractions, if you are not comfortable but could have access to those 4 steps, you could do it. Are my hopes correct? So like where I talked yesterday about being that teacher that gets my hopes up thinking everybody's gonna know how to do this, and I think everybody's gonna get an A or a B on this test. Do you feel like today, if you had a test and the only thing on the test was dividing fractions, that you would get an A or a B?
Yeah.
So, where do you feel like you would go wrong? Yes? Huh? Move your body here to this desk for this class. Because these 4 steps right here, without me even being your teacher, if you have those 4 steps and you follow them and you don't make any multiplication errors and you don't make any subtraction errors and you don't make any division errors, should you be able to follow the steps and get to the finish line? Yeah, you should. What?
It's like, if you just show me that today and you divide fractions, I would not have to keep saying flip it now that I know what it means, I just do it.
Absolutely, yeah. So, that's hopeful. That's why I stand in front of you and I get my hopes up thinking, yeah, these people know what they're doing. But remember, it's a 2-way street. I'm the teacher, but you have to be the learner. So if I'm doing all the work and you're not doing any of the work with me, are you gonna get to where you understand this stuff? No. So I can't do your job for you, you have to do that job for yourself. So before we jump into today's class, or today's lesson, okay, we're gonna finish with one final dividing mixed numbers problem, okay? Because on your test on the 19th of May, there's only gonna be one of these. Because remember, the book doesn't even, chapter 9 doesn't even get into dividing mixed numbers at all. All chapter 9 expects you to know how to do is divide a fraction in a whole number. And that was like the first example that we did when we started playing with this stuff. That's all the entire chapter, things that you're capable of. And as your teacher, I know that you're capable of way more than that. So if you have that formula, you can do it. As Sophia said, if you know what keep, change, flip means, then all you do is follow the formula and you get to what you need. What?
I gave you Disney on my pencil yesterday, I wish you took it.
Oh, just grab a new one then. Do I have another one off the desk there? It's a little kid that comes to my room, and I tutor him after school. Yeah. Okay, so let's try one just to make sure you guys didn't forget or don't accidentally skip one of these 4 steps. Because when you are solving a problem where you have to divide mixed numbers, you can't skip step 1. And that's something that a lot of people have a tendency to do. What?
No, I know step 1.
Oh, what is step 1?
You turn the mixed number into an improper fraction.
All right, perfect. And that goes with multiplication too, right? If I gave you a problem and it was a multiplying mixed numbers problem, would you turn mixed numbers into improper fractions for those? Yes, you do this for both multiplication and division. Okay, so let's try it. Let's go with 7 2/3. Actually, I don't like that one because it may end up with you having to do too much multiplication. So let's change this. Let's go with 8 2/3. Okay, divided by 4 and let me think. 4 2/4. Okay. just made this one up. It could be somewhat difficult, but follow that formula. Follow those steps. This is to wake your brain up since it's 8:15 Wednesday morning. So we get into what the new stuff's gonna be. It was a little bit of a doozy. Hey, once you get an answer, just kind of chill for a sec so that we can let everybody else have a chance to come up with an answer. I know we got some people still working, but I want to share an answer they got. Bring them together.
1 and 25 over 27.
1 and 25 over 27, okay, that's an answer that's in my thought. Maybe something different, what'd you get?
1 and 5 over 9.
1 and 5 over 9, okay? Maybe something else? What'd you get?
For some reason, I got 26 over 27.
Okay. 26 over 27. Anybody else get something different? Yeah?
I got 22 over 27.
22 over 27. Anybody else? Yeah?
1 and 15, 27.
1 and 15, what?
27.
27, okay. Anybody else? Yeah?
39.
39? Okay. All right, so it appears that we got answers that are kind of all over the place. For those of you that didn't offer an answer, is your answer possibly one of the ones that are listed here?
Yes.
Okay, how many of you have 39 as your answer? Let's just see if we were playing the game of Who Wants to Be a Millionaire, and we asked the audience for help. All right, what about 1 and 25, 27s? Ooh, we got 1, 2, 3, 4, 5, 6, 7 people that like that answer, okay? What about 1 and 5 9s? 1, 2, 3, 4. We got 4 people that like that answer. What about 26 27s? All right. What about 22 27s? What about 1 and 15 27s? Okay. So if we were playing that game, obviously the majority of the people in here are thinking that the answer is 1 and 25 27s. But out of a class of today, what do we got? 24? 24 people. Only 7 people are thinking that the answer is that one. So that might mean I have a lot of people who are not volunteering what they got. So let's work this thing together and see what we get. All right. So the first thing we have to do is change this thing to a improper fraction. Brady, what is 8 and 2/3 as an improper fraction?
26 over 3.
It is. It's 26 over 3. Okay. I'm going to keep my division sign because I'm still doing step 1. All right. What is 4 and 2/4 as an improper fraction? James.
4 over 18.
What is it?
18 over 4.
There you go.
James, you
Okay.
already
Now, James is moving on to step 2, okay? Now, we've moved on, so far, check and see your work and see if what you've done so far is working. Okay, all right, now we're ready for step 3. Step 3 is keep, change, flip. So tell me what is my stuff gonna look like, Colin, when I keep, change, flip?
You keep 26 over 3, and then you change the division sign to a multiplication sign, and then you flip 18 over 4, or 18 over 4 and 4 over 18.
Thanks, Colin, perfectly said, okay? All right, now we're ready for step 3. And step 3 says simplify before you multiply. So Sophia, 26 over 3 and 4 over 18. First off, how many of you all have that? Have you made it to my green stuff yet? Okay, all right, now let's change to a new color so that we can see our new steps. So Sophia, I want you to simplify before you multiply. So where do you see we can simplify?
26 and 18.
26.
They both go at 0.
They do. So if I slice this thing by 2,
It'd be 13. Because 2 goes into 26. 13.
okay, what's 18?
Goes into a 9.
Perfect. What about the other direction?
Nothing.
Can't do anything. So who's with me now? Okay, so we're all still together, most of us. For those people that have now fallen off the tracks, did you find where you fell off the tracks? Okay, perfect. All right, so now we are nothing left to simplify, so now we're ready to step 4. Just multiply this stuff that's left. So let's change to yellow, okay? We're gonna multiply what's left. So at the top I've got 13 times 4. Max, what's 13 times 4?
52.
13 times 4 is 52. What's 9 times 3, Max?
27.
It is 27, okay? How many of you have 52 over 27?
I did it. I really did it.
Perfect, okay. Final step, here we go. All right, so now we have to simplify again because we can't leave this thing as a 52 over a 27 because it is a good. So that means, and this is where so many people still are having those errors. If the top number is bigger than the bottom number, in fraction world, to simplify it, you have to flip it on its side and divide. Now, some of you are doing that in your head, and that's cool, that's great. But for those people who still need to see it being worked out, they're gonna turn this thing on its side, they're going to put 52 in the box, and they are going to put 27 on the outside. How many 27s will fit into 52? Max?
1.
Just 1. Now, we've reached this part now where we can't let, all the hard stuff was that fraction stuff. Now we've reached this division stuff, so we can't let this old school math, this little division, this little subtraction stuff cause our problem, okay? When we subtract here, Brody, I gotta do 52 minus 27, so what am I gonna have to do? I gotta borrow. 5's gonna turn into a?
1.
And 2's gonna turn into a?
1.
12.
Or 12.
And turn into a 12. 12 minus 7 is?
5.
Okay. And 4 minus 2 is?
2.
Now, I have nothing left to divide. So that stuff that's left has to become what would be my remainder. But now that we're playing with fractions, it's the top number of the fraction, right? And the bottom number is whatever's on that outside. So 1 and 25 27s.
I had to subtract.
Who got it? Excellent. Now, how come if all of you people had 1 and 25 27s, I don't see more than 7 next to that answer?
I just got it just now.
Just now? How many of you got it though at the very start? 1, 2, 3, 4, 5, 6. So there's my 7 people that got it right from the very start. How many of you found where you went wrong? Where'd you go wrong, Brady? Where'd you go wrong, Carson? Where'd you go wrong? Where'd you go wrong? Huh? Holy smokes, that's step 2. Where'd you go wrong? Where'd you go wrong? Where'd you go wrong? Where'd you go wrong? Subtraction.
I forgot to flip.
Yeah.
I said like 4.
What'd you do?
I simplified 4.
Oh, so wait a minute. 4 and 3 you simplified?
I
so comfortable with you all, he's just gonna admit it. That's totally good. But look how many of you guys made a mistake on something that's not even related to fifth grade math. When you get to the step where you have to subtract, when you get to the steps where you have to multiply, that's the stuff you gotta really focus on, because that's when simple errors happen.
Because
Your brain was so focused on those 4 steps that it was really slowing down and making sure it did everything right. Then you got to the part where all the stuff you had left to do was stuff that you learned how to do a couple of years ago. And now you stopped focusing and you started blasting through it. And then before you know it, silly errors happen. Okay? So, there's only one of those kinds of problems that are gonna show up on your test. The rest of them are not gonna be mixed numbers. Instead, they are just going to be problems that look like this purple one right here. Just simply dividing a fraction by a fraction. Hang on one second. What?
Can I have all mixed numbers on mine?
You cannot, but I can tell you what I can offer you is I will offer you a bonus question for your quiz, for your test, and it'll be a 5-point bonus question. And it'll be one like that one you just completed a second ago. Okay? So that's what I can offer. All right, so now I would love to keep doing these because I think you guys kind of like them, but we have to move on to what the next skill is going to be that you're going to learn. So that means we gotta go to our new page because we gotta learn some new stuff. And today we're gonna learn how to multiply decimals. Yes. Oh, I'm not talking about that here. Okay, this class is getting a little bit anxious and loud. Okay, please let's stay focused. I don't have that much time to teach you. So the little time I got, I can't waste. I need you to finish your private conversations. Okay, so it's been a while since we've seen decimals. The last time we played with decimals, we were adding and subtracting them. And the thing that we learned way back then is what? Who can remember with addition and subtraction, what was the major thing you had to remember to do? Xander. Thank you, Xander. You had to line up those decimals. But guess what? With multiplication and division, you really don't. Okay? So this is again a place where division and multiplication are different than addition and subtraction. Remember, with addition and subtraction of fractions, you could like work the fractions first and then do the whole numbers after that. Remember that? But then when we moved into multiplication and division, you couldn't do that. You had to change everything into this improper fraction stuff. So just like stuff changes in fraction world between multiplication and addition, it's going to change with decimals between multiplication and addition. With this stuff, you don't have to line things up, okay? You're just going to simply multiply numbers. And then we're going to put the decimal back into the answer where it belongs. Now, I want to show you something to make sure that you haven't forgotten some things. First off, when I look at a number like this, okay, and I'm just going to make a number up. That's a number that contains a decimal, right? But that number has a name. If I asked you to say the name of that number, Dominic, what would that number's name be?
9.
Sorry.
I'm getting it confused with fractions.
You don't get
9.2.
No, I like what you're gonna do first. What you were gonna do first was gonna come out right. Because in decimal world, what does the decimal mean? It means a word. What you were about to say it. What word was it means and. So what were you gonna say that this is?
9 and 2. 9 and 2 tenths.
That's what it is. It's 9 and 2 tenths. I wouldn't say 9.2. Okay? Because in decimal world, the decimal represents the word and, which way back in chapter 1, and things are even falling off the wall. You see here up there, right above the decimal is that tiny little and word. To get you to remember that when you do see a decimal, it means the word and. So if this decimal right here has a name of 9 and 2/10, how do you think you would turn that into a fraction? Huh? If I told you to come to the board and I said, write the fraction 9 and 2/10 on the board, what would you write? You're making this harder than what it is. Shane,
It's just 9 and 2/10.
so how would I write it?
9 and then 2/10.
Like that.
Well, that's easy.
These guys are the same thing. A 9.2, which has a name of 9 and 2/10, in fraction world turns into a mixed number. 9 and 2/10. Now do you see why mixed numbers are greater than 1?
Yes.
Because like this number here is 9 and a little more, this fraction is 9 and a little more. So we're going to talk about multiplying decimals. So there's actually 2 ways you can do it, and I'm going to show you both, and I'm going to let you decide what you think is the easiest. All right? So let's check out this quick little example, okay? Now, just listen first, and then I'll let you write in a second. So let's say that I gave you a problem like 1.2 times 2.4, okay? There's actually 2 ways that you can solve this thing. The first way is you can change each of those decimal numbers to a fraction. You could. So what would 1.2 look like as a fraction? What would it look like? It would be 1 and 2/10. And what would 2.4 look like as a fraction, Tessa?
2 and 4.
Yeah. And now you've set this problem up as I'm multiplying a mixed number by a mixed number, which you've already been taught to do. Now, that's one way you can do it. Personally, I think that's a longer way. But I wanted to just throw it at you and say, look, that's an option. You could take each of those decimal numbers, you can change them to fractions, and then multiply fractions like you've already been taught how to do, okay? But the easier way is to do this, okay? So to me, I'm gonna call this the long way, okay? And when you go the long way, do you have a chance of making a wrong turn?
Yes.
It's kind of like you're driving your car and you were heading to a destination and you took the long way. It's gonna take you longer to get there. And it's also you're gonna have a chance that you might run into some trouble. Okay? The short way is gonna be this. The short way is to simply take, hang on just a second, I'm gonna have to move this down and then back up. Okay, is to take the number that you started with. So we started with a 1.2 and a 2.4. And I'm just gonna simply say for a minute, remove those decimals and what numbers do you see?
12 and 24.
You see a 12 and 24. And just multiply 12 and 24. Isn't that a lot easier? Now there are 2 ways to do it. That's why I wanted to show you. I mean, if you're somebody who loves multiplying fractions, you might want to do it that way, and that's fine. You're gonna get the right answer if you go that way. It's just the longer route. I think the easier way to get there is to simply look in the problem and just pretend like the decimal isn't there. If I were to remove the decimal from that first number, a 1 and a 2 together would make a 12. And if I remove the decimal from this number, a 2 and a 4 would make a 24. And then all I would have to do is multiply 24 times 12. Okay? So let's come over here, let's do it. Okay? And this is where I say to you now, I can't help you if you make multiplication errors. This is something that you should have come into 5th grade already knowing how to do. Okay? So very carefully, we're going to solve this thing. 4 times 2 is? 2 times 4 is? 2 times 2 is 4. Okay? Now we have to put our 0 placeholder, right? 1 times 4 is? 1 times 2 is? Line those things up, now add them up, and what do I get? I get 288, okay? Now, is that my final answer? No, because I started with decimals, so now I gotta make sure my answer has a decimal. So how do I know where it goes? Well, now I've gotta come back to the original problem. So see, this is why I say don't erase things, because if you would have erased the decimal, you wouldn't know where it started. And it's critical to know where it started. So when I look back here at this problem, and I look at where the decimal is sitting, I have to figure out how many digits are behind the decimal point. Well, in 1.2, how many digits do you see sitting after a decimal? Carson? Just one. The 2 is the only thing sitting behind the decimal, right? Carson, go over to the other number. How many digits in that number are after the decimal? Just one. So in total, Carson, in that whole problem, how many digits are after the decimal point? 2. Everybody see where that came from? So that means we have to make it match that in our answer. So if 2 digits are behind the decimal in the problem, then there has to be 2 digits after the decimal in my answer. And your answer becomes 2.88. What?
If there was like a lot of digits behind like each number you were multiplying,
Olivia, stop doing that.
then you finished like multiplying it and you got an answer and it was like there wasn't enough numbers to go behind additional, would you just add zeros?
Oh, good question. We're getting ready to get there. Yeah, but you would. But the question is, where would you add those zeros? So let's try one like that, okay? All right, so let me get into my book. So here's the question she's asking. She wants to know if we do all the multiplication and you have to put your decimal back in your answer, what happens if there's not enough digits? So that's her question. And we're gonna get to that, but I don't wanna jump there just yet. I want you guys to try a problem on your own that I don't walk myself through with you, okay? So I'm gonna move my screen down, okay? And I'm gonna give you guys another example. And I want you all to try this one without me walking you through it, okay? So let's try, let's try this one. They're a little on the longer side. All right, let's do this one. 8.3 times 0.24. Okay. Now, I like that example because it has a 0 in there. So real quickly, how many of you are choosing to take the short way to solve this thing? So you're going to just multiply these as numbers, right? So if I remove the decimal from the first number, what number would that become, everybody? 83. If I remove the decimal from that other number, what would it become? It would just become a 24. So that 0 that's going to sit in front is not doing anything. It's not adding any value. So when you set up your multiplication, don't set it up as multiplying it by 024. 024 is the same as 24. So you would just set this problem up 83 times 24 and solve.
Pardon the interruption. Today, from 10:45 till noon, you cannot use the PAC nor the gym. Thank you.
I think,
Well,
no,
Miss Isaac's gone, she's not.
I'm not really sure what's going on, but.
There could be
All right, we're not getting off topic. Stay focused. Multiply these things together and get the digits that you need in the answer. And be careful. This is where silly mistakes happen. I can't stop those silly mistakes. You're the only one who can. You're the one holding the pencil. You're the one writing the numbers. So if those errors are happening, hang on, bud. I can't stop that. You're the one that has to be in charge of those mistakes. All right, so when you multiplied all this stuff together, tell me the digits you got as an answer, not where the decimal is. I just want to know what numbers do you have in your answer. Connor, what numbers do you have?
2, 0, 8, 4.
Okay, then I'm gonna say something went wrong with your multiplication, because those shouldn't be the digits that you have in your answer. Cassidy,
1, 9, 9, 2.
that's what you should have. You should have a 1, a 9, a 9, and a 2. So re-look at your multiplication and see if something went wrong, okay? But once you multiplied all that stuff together, you should have gotten a 1992. Who got that? All right, now the big question is, where does the decimal go? So let's go into the problem. The problem has 1 digit after a decimal point in the first number, but it has 2 digits after the decimal point in the second number. So that makes a total of how many digits after decimals? 3. So in your answer, Tessa, where's the decimal going to go?
You would have to add a 0 when you
You shouldn't. You shouldn't have to, because I have 3 digits after decimals in the problem, so I need to have 3 digits after the decimal in my answer.
after the 1.
It's gonna go after the 1. So your answer should be 1.992. Okay? What?
So for like the first one you did, I did under fractions, and I don't understand how you did the fractions.
Well, you still have to take those fractions and turn them into, improper, you have to change them to mixed numbers, right? Then you have to change them back to improper fractions. Then you have to simplify before you multiply. And then you would get a fraction as an answer. So you might get a fraction that would be something like 1 and 992 thousandths. So that's what you would get as a fraction, because that's what that number turns into as a fraction or as a mixed number. Okay? Do you see how that would take a longer way to get there? Yeah. So now let's look at her answer, her question, Addison's question, which was about this whole zeros thing. All right. Let me see if I can create a problem that will have you look at something that way. Okay, let's try one last one. Here we go. All right. Our last problem, I think, is going to give you a situation where you're going to have to add some zeros. So, all right. So let's try this one. Here we go. Ready? 0.005 times 4. Okay. All right, people. So if we do this the way that we talked about earlier, where we just pretend like the decimals aren't there, what number would we be looking at for the first one? Braden, we'd just be looking at a 5. This thing would just be a 5. Doesn't matter if it has 25 zeros in front of it, it's still a 5, right? Because all those zeros in front don't give it any value. So this would just be a 5, and that would just be a 4. So if we multiplied those together, what would we get? We don't even need to write it down, do we? We'd get 20, okay? So the big question is, where's the decimal going to go? So let's look in the problem. How many digits are after the decimal point in the problem? 3. Boom, boom, boom. These 3. That means there needs to be 3 digits after a decimal point in the answer. But my issue is I only have 2 digits in the answer. Where can I add a 0 where it's not going to change the value of that number? Brody, Brody.
You can put it at the back.
But check this out. If I put it at the back, that 20 has now turned into what?
Oh, 200.
That's turned into a 200. I can't change the value.
You put it in the front.
Nice. I'm going to stick that thing in the front too. Because now, what's that number? It's still 20. Notice how when I put that 0 in the front, it didn't change its value at all? So then, where does the decimal go? Right in front of that 0. Huh?
Couldn't we keep it because of equivalent decimals?
What do you mean?
Couldn't we not put the fraction thing there because of equivalent decimal?
Not keep the fraction there.
I mean, not the fraction, the decimal. We you had to add zero because it doesn't change the value.
It does change the value though. Because look, if you don't have that 0 there, buddy, and like, let's just say that you put the decimal right in front of the 2. What's that number's name?
2/10.
2/10. So if I put a 0 in front of it, what's its name?
200.
So do you see how they're different numbers?
No, I meant remove the zero in front of the number. No, the other one.
The blue one?
Yeah.
You can't remove that one.
Oh.
You can only remove zeros when they're at the end.
Oh.
So yeah, like in this, I think now what I understand you asking is, can you get rid of the yellow 0 at the back?
No, I meant the blue one in the front.
Can't get rid of the blue one in the front. It's holding a spot, and that's an important spot that it's holding. But could you drop that 0 in the back? Yeah, you can. You can drop that 0 in the back. Zeros at the end in decimal world, we learned this way long time ago. We don't need those guys at the end. If you left it there, that's fine. So like if you told me that the answer was 0.020, I would say you're good. You got the right answer. Or if you told me the answer was 0.02, I would say you're good. You got the answer. Because they're the same thing. Okay? Y'all want to try one more? All right. Are we done? I think I'm totally done. I'm totally done. Okay, so here's what you guys are gonna do. Tonight, you're not gonna work on any of these kind that have this 0 stuff. You're just gonna simply work on the ones that we did up above, okay? So tomorrow, we'll play with some more of these that have the zeros, but for tonight, what I want you to do in your workbook, you are going to, and I've gotta look at what page, who's my homework helper right now? Would you head to the board and write this down, whoever my homework helper is? Brody, you the homework guy? All right, so Brody, I want you to write, we're going to work page 207 in our workbook. And you guys are only gonna complete 1 through 10. Okay? That's it, that's your homework, okay? Yep.